Today we are back with the third video in the binomial expansion series. So in the first video, we talked about binomial theorem and we learned how to use the theorem to do expansion. In the second video, we talked about the general term and we learned how to use it to find a specific term. So in today's video, we're going to talk about product of expansion. Let me just briefly explain to you what I mean when I say product of expansion. So product of expansion really means a question where we have an expansion, maybe 2 minus 5x to the power of, let's say, 7. So this is an expansion, and on top of this expansion, you need to multiply it with another factor, say maybe 3 minus 5x, something like that. Okay? So there is an expansion, and then there is a product. Alright, the best way to go through this kind of question is to look at examples. So you can see I already have my example one here. The question asks you to write down and simplify the first four terms in the expansion of 3 plus 2x to the power 5. And it says that they want it in ascending powers of x. Ascending powers of x really just means that the power of x has to be increasing. So if I do my expansion and I end up with something like, let's say something like this. This is ascending powers of x because I go from the powers of x went from 2 to 4 to 6, so it is increasing. On the other hand, if I have something like maybe 10 x to the power of 12 plus say 15 x to the power of 10 and minus maybe 2 x to the power of 8, then this is descending powers of x because it went from 12 to 10 to 8. Right? So with that, let us look at this question here. The first part is quite straightforward. You should be quite familiar with doing this expansion by now. So let me just write down the solution quickly. 3 plus 2x to the power of 5. And I only want the first four terms. Now I add on my n, a, b, n, a, b. And then we know that this number here goes from 0, 1, 2, 3. And within the powers of x, the powers, this is 0 and 5. This is 1, 4, 2. 5 minus 2 is 3. This is 3 and this is 2. The next step is to simplify it. Well, for the first one, it's quite straightforward because this is just 1 and this is 1. So we end up with 3 to the power of 5. And that gives me 2, 4, 3. Plus, the second one, we have 5 choose 1 and 3 to the power of 4 and 2 to the power of 1. So that gives me 810. Now for this one, we don't have to worry about the sign because everything is positive. So it will definitely be a positive sign. And then this is x to the power of 1. So that's just x. Then the next one, we have 5 choose 2 times 3 cube times 2 square. So that is 1080. And this is x square. Plus, then this is 5 choose 3 times 3 square times 2 cube. So that gives me 720x cube plus dot dot dot. So this is the first part where I need to do my expansion. Now the second part is what is new. So the second part, you need to take this expansion and multiply it with 2 minus x. So let's see, we have 2 minus x and we need to multiply it with the expansion. So since we have already done the expansion in the first part, let me just update it. So this is 2 minus x, and for this one here, let me just use a different color. So maybe this. Okay. So 3 plus 2x to the power 5. And so 2 minus x, and the other one is 3 plus 2x to the power 5. We have already expanded that. That gives me 243 plus 810x plus 1080x squared plus 720x cubed plus dot dot dot. Okay, now I'm ready to do my multiplication. I need to multiply the green factor with the orange factor. The multiplication, we have to be smart about it because we cannot do all the multiplication. A lot of the terms will be wasted. This is how I would normally do it. I will take the smaller bracket, okay, so-called smaller bracket, which is the bracket that is that has fewer terms. If you look at this one here, this bracket here has 2 terms, whereas this bracket here has 1, 2, 3, 4 terms. So what I'll do is I will look at the one with the fewer number of terms, which is this one here, and I will try to pair everybody in that smaller bracket with one of the terms in the other bracket. Let me show you what I mean. So I will look at 2 minus x. The first term is a 2 because the question is asking for x cubed. So I ask myself, who can I pair 2 with in the orange bracket? Can I pair it with 243? No, I'm not going to get x cubed. Can I pair it with 810x? No. Can I pair it with 1080x squared? Again, no. So I realized that I can only pair my 2 with 720x cubed to get an x cubed term. What about for x? X, can I pair with 243? No, because I'm going to get an x term. Can I pair with 810x? Again, no, because I'm going to get an x squared term. Can I pair with 1080x squared? Aha! An x multiplied with 1080x squared gives me an x cubed term. So I can multiply this with 1080x squared. So in other words, instead of doing all the multiplication, I only need to do 2 multiplication, which is I can take 2 multiplied with 720 x cubed, and I will take my x multiplied with 1080x squared. In fact, this is a negative x, so I can take my negative x because of this negative sign here. So it will be negative x multiplied with 1080x squared plus dot dot dot. Because these are the only 2 multiplication that will give me my x cubed term. So you just evaluate these and you're going to get 360 x cubed plus dot dot dot. So that's it. So for this question, there is a fast way to do it, which is to only multiply what you need, and there is a very tedious way to do it, which is to do all the multiplication. So of course we have to be smart and we only multiply what we need. So for this one, they ask for the coefficient of x cubed. So I will just conclude that I say therefore coefficient is equals to, coefficient means without the x, so I would means just the number there, so I will just say the answer is 360. Okay, this is example 1. I hope this is clear, because let's go on to example 2 now. Let me just paste it in. Example 2 is a very similar question. It's just that they didn't give you a part 1, so you need to do the expansion yourself. Okay. But example 2 actually offers us an even shorter way to do it. Now let's look at the solution for this question. Now here I want the coefficient of x to the power 5 in this expansion here. Let's first write down, we have 2x minus 1 to the power 6 and 3x plus 1. Now we are not going to do this full expansion, but let me ask you, if we do a full expansion, how many terms are we going to get? Because remember, when we do our expansion, we start from 6 choose 0. That's the first one. 6 choose 0, it will be 2x and then minus 1, 0 and 6. That's our first term. And then the second term will be 6 choose 1 and then 6 choose 2 and all the way until 6 choose 6. Because it starts from 0, 1, 2, 3, 4, 5, 6, we're actually going to have 6 terms here plus 1 here. So we're going to end up with a total of 7 terms. Okay. So this bracket, we have 7 terms, and this bracket we have only 2 terms. So the smaller bracket is the 3x plus 1 bracket. So if that's the case, I'm going to focus on the 3x plus 1 factor. So 3x plus 1 and 2x minus 1 to the power 6. Now 3x plus 1 I don't know what is the expansion of the second one. I'm just going to leave it blank. But let me just put some dummy terms inside. Now, if we look at 2x minus 1 to the power 6, we know that the first term, we have it over here. If you simplify, you will get x to the power 6. So let me just say that maybe this is just a x to the power 6. I'm not going to find the coefficient first. And then the next one will actually be x to the power 5. So let's say that is plus b x to the power 5. And then the next one, it will actually be c x to the power 4. Then plus d x to the power 3 plus, what's that, a, b, c, d, e, x squared plus f x and maybe plus g. This is how the expansion will look like if I really do the expansion. But I'm not going to find out what's my a, b, c, d, e, f, g. Instead, I'm only going to find the terms that I need. So let's do the pairing. We know that 3x plus 1 is the smaller bracket. So let's see. If I take 3x, who can I multiply it with to give me x to the power 5, which is what the question wants. I believe you should be able to figure out that 3x has to be multiplied with c x to the power 4 to give me x to the power 5. And then the next term, which is 1 here, who can I multiply with to give me x to the power 5? So that should be with b x to the power 5. So in other words, I actually do not need ax6. I do not need dx cubed, ex squared, fx, or g. What I really need is just the x to the power 5 term and the x to the power 4 term. So one easy way to do this question is really to use our general term. So let me just write down the general term. So we look at the first one. I want the bx5 term, okay, which is the x to the power 5 term. Because my general term for this question, the general term, there is no x here and there is no x here. So there is only the second bracket has an x. Therefore, it makes it very easy for us to figure out what is the x to the power 5 term. We just need to set these to 5, which means my r is 1. So I can say x to the power 5 term, which is r equals to 1, because 6 minus r has to be 5. So r is 1. So that is equals to 6 choose 1, 2x, 5, and negative 1, 1. If you simplify that, you're going to get negative 192 x to the power 5. The next one, we know we need the x to the power 4 term. So my x4 term is, can you tell me what is the value of r that we need? We need r equals to 2 because we want this one here to be 4. So r equals to 2. So that is 6 choose 2, 2x, negative 1. So this is 2 and this is 4. If you simplify this, you are going to get 240 x to the power 4. Now I have the two terms that I need, and we have concluded earlier that we simply need to take 3x and multiply it with the x to the power 4 term plus 1 multiplying it with the x to the power 5 term. So therefore, the x5 term is equals to, take 3x times cx4, so 3x times cx4, and c I found that is 240, so it's 240 x4 plus 1 times bx5, 1 times bx5, which we know that is negative 192, and that is going to give me 528 x to the power 5. And since they only ask for the coefficient, I will conclude and say that therefore coefficient is equals to 5 to 8. So that's it for example 2. One final example. Okay, for this question, we need to do quite a few expansion. So I'm going to do it quickly. So I hope you get the same answer. The second one, part B, is slightly harder because of the negative sign. Okay, so simplifying this, we get 64. Now for this one here is 6 choose 1 times 2 to the power 5 times 1 over 3. There's 64 as well. My sign, the sign you have to be careful because this is a negative sign and it's raised to the power 1. That's why it's negative here. And then it's just x. Plus, the last one is 6 choose 2 times 2 to the power 4 times 1 over 3 squared, which gives me 80 over 3. But because this is negative and it's square, so it's just positive, and x squared plus dot dot dot. Okay, so we've done part 1 and part 2. So now part C and part D. Hence means it is related to part A and part B. So the first one, part C, they ask you to find the value of 3.002 to the power 6 correct to 4 decimal places. Because of the word hence, we know that it is definitely related to the previous parts. If you look at part A and part B, which part do you think is related to? Part A or part B? I guess we should be more inclined to say that it is part A because there's a 3 here and this one there's also a 3. Okay? There's a 2 here and there's also a 2, right? So the way to do part C is to actually make use of your part A and substitute a suitable value of x so that 3 plus 2x becomes 3.002. Notice that the power is the same. We already know that 3 plus 2x from part A, we know that this is 729 plus 2916x plus 4860x squared dot dot dot. Okay, we want to make 3 plus 2x into 3.002. You can just do it using observation. We can say that 3.002 can be written as 3 plus 0.002. We have the 3. So the next one is just 2 times x. So this one can be written as 3 plus 2 times 0.001. So that allows us to map 3.002 to 3 plus 2x. Using this observation, we can conclude that x is equals to 0.001. This is doing it by observation. Of course, we can also equate the two and solve it. So alternatively, what you can do is you can just do a 3 plus 2x equals to 3.002, equate the two, and then you just solve for x. So 2x is 0.002 and x is 0.001. So either way will work. We like to use powers of 10 as our x. In this case, it's actually this one here is actually 10 to the power negative 4. The reason is because it is a lot easier for us to work with powers of 10, especially if you don't have a calculator. So if I ask you to give me 10 cube, you can tell me that it's just 1000. Okay, so anyway, we prefer, normally the x that we choose will always be a multiple of 10, will be a power of 10. So now that we have the x value, we can substitute x equals to 0.001 into, let me call this equation number 1. We just substitute it into equation number 1. So the left side is 3 plus 2x, which is 2 times 0.001 to the power of 6, and that is equals to 729 plus 2916 times 0.001 plus 4860 0.001 square plus dot dot dot. And if you simplify this using your calculator, you will get 731.9209. So that is your answer for part C. Now maybe some of you may be wondering, why is it that we don't, because here when we do our expansion 3 plus 2x to the power of 6, we know that we are actually going to get a total of 7 terms. But what we have here is just the first 3 terms. Why do we still get the correct answer when we omitted the last 4 terms? The reason is because the last 4 terms, the power of x is going to be x cubed and so on. So if you think about, if x is 0.001 and you cube it, you're actually going to get 0.000000001, which is very small, and it will not affect the first 4 decimal places. Since the question only wants up to the first 4 decimal places, it's not going to affect our answer. We move on to the last part, part D, which requires us to find the coefficient of x squared in the expansion of 6 plus 3x minus 2 over 3x squared to the power of 6. Now, for this question, firstly, the first clue is that it says hence. So, we know that it is related to part A and part B. But the second thing is, for this expansion here, there are actually 3 terms inside. We have 6, we have 3x, and we have negative 2 over 3x squared. So binomial theorem is for 2 terms. So we cannot use binomial theorem to expand this because there are 3 terms here. So this is more like trinomial theorem, which we have not covered. Therefore, that tells us that we definitely have to use part A and part B. So what you notice is that part A, it is to the power of 6, and part B, it is also to the power of 6. And what we want here is also to the power of 6. And if you look at part A and part B, this is linear, and this is linear. Whereas this one here is quadratic. Okay, I hope you can guess that actually, if you multiply part A and part B, you're going to get part D. Now let's see what I mean. Part D, so we want to expand 6 plus 3x minus 2 thirds x squared. But part A, we have 3 plus 2x, and we have 2 minus 1 third x. If I multiply these two, 3 plus 2x and 2 minus 1 third x. Let me put a power 6 and a power 6. Now from laws of indices, we know that we can take the, because the power is the same, so we can take it out and we can write it like that. 3 plus 2x, 2 minus 1 third x, power 6. This is laws of indices. And inside the square bracket, let me just expand it. So 3 minus 3 times 2, 6. 3 times negative 1 third x, that gives me negative x. 2x times 2, that is 4x. And 2x times negative 1 third x, that gives me negative 2 over 3 x squared to the power of 6. And if you simplify this, you get 6 plus 3x minus 2 over 3 x squared to the power of 6, which is what part D wants. So part D is actually a product of expansion. In other words, I can now say that 6 plus 3x minus 2 over 3 x squared to the power of 6 is equals to 3 plus 2x to the power of 6 multiplied with 2 minus 1 over 3 x to the power of 6. Okay, and then we have already expanded this, which is 729 plus 2916x plus 4860x squared. So this is 729 plus 2916x plus 4860x squared plus dot dot dot. The other one is 64 minus 64x plus 80 over 3 x squared plus dot dot dot. Okay, so this is from part A and part B. And now I want the coefficient of x squared. So we know that if we want the coefficient of x squared, we don't have to do the full expansion. We don't need to multiply everybody here with everybody here. Now here for this one, I have 3 terms here, and I also have 3 terms here. So it really doesn't matter which factor I work with. So I'm going to look at the first bracket, and I'm going to do the pairing. So 729 can be multiplied with, what do we want? We want x squared, okay. Can be multiplied with this to give me my x squared term. So let me write it down. 729 times 80 over 3 x squared plus the next one. Let me use a green color maybe. 2916 can be multiplied with negative 64x. So that is plus 2916x times negative 64x plus the last one. I'll use black. 4860 x squared can be multiplied with 64. So 4860 x squared can be multiplied with 64 plus dot dot dot. Dot dot is all those that I didn't bother to multiply. For instance, I didn't bother to multiply 729 with 64 because that is not going to give me my x squared. So this is what the dot 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 represents, all those that we didn't multiply. So if you simplify this, you are finally going to get 143,856 x squared plus dot dot dot. So again, I think the question is asking for the coefficient. Therefore, coefficient is equal to 143,856. That's it. Okay, so thank you for watching. In the next video, we are going to talk about, so we've covered these. So in the next one, we're going to look at how to expand 3 terms. We have already done one example in this video, but the next video is going to teach you 2 different methods to expand 3 terms. Okay, thank you.